Now let's take a look at the empirical evidence on the Fisher equation. First, let's take a look at the US data. The Fisher equation suggests that there's a one-on-one relationship between the nominal interest rate and the inflation rate. So on this figure, we look at in the United States between 1954 till recent years. We put both nominal interest rate and the inflation rate on the chart, okay? And the green one is a nominal interest rate and the red one is inflation rate, okay? Once again, here let's focus on the long-term relationship, okay? And you can find that the evidence is in favor of the Fisher equation, okay? So we believe there's a strong positive correlation between these two variables. Here you find that the correlation coefficient is 0.76. Okay? If you remember from your stats course, we said that if the correlation coefficient between two variables equal to 1, that means these two variables are 100% positively correlated. In other words, they are completely overlapping. Okay? If the correlation coefficient equals 0, that means there's no correlation between the two variables. Now here 0.76 is closer to 1, so that means there's a strong positive correlation between these two. Okay? Once again, please focus on the long-term trend instead of the short run. Okay? For example, especially in recent years, you may find that these two variables could move even in opposite directions. Okay? But as we said before, this is possibly because of the Federal Reserve conducted the counter-cyclical monetary policy. Okay? So look at the long term. Okay? All right, and the second piece of the empirical evidence is cross-country comparison. Okay? Once again, we're still looking at the relationship between nominal interest rate and inflation rate. All right. Here we put a sample of countries on this chart, and every green dot or square represent one country. Okay, and of course across the sample we find a strong positive correlation, okay, between these two. So the evidence is in favor of the Fisher equation as well. Okay, and now let's take a look at the real interest rates. Okay, here we said there are actually two real interest rates, ex-ante rate and ex-post rate. This is because, again, we don't know the real interest rate ahead of time, right? Now here, let's use a very simple hypothetical, the real-world investment decision to show you the difference between these two real interest rates. Okay? Now, the investors face this decision if the real interest rate R equals 5% and the expected inflation is 2%. Will you purchase a corporate bond with nominal interest rate equal to 8%? All right. So here you probably want to know, like the expected inflation. You can, have your own expectation of inflation based upon all kinds of the information you have, right? In other words, you can do your own calculation. You can make your own inflation projection. But where exactly you can find the real interest rate ahead of time, right? This is actually what we'll call ex ante real interest rate. Okay. Now, the ex ante real interest rate actually, in reality, you can look at the other options you have. For example, here we're talking about purchasing a corporate bond, right? In reality, you could have other options like stocks you could buy or treasury bonds, right? Or even the other like real estate investment, how much return you could get. In other words, here R can be considered as the second best return rate. Okay. In other words, if you don't want to buy the corporate bonds, then what will be the highest return you could receive from other possible investment? Okay. For example, in this case, let's say if you don't buy the bond, you want purchase stocks. Okay. And from that, you can earn 5% return rate, okay, from your stock investment. So that's how we, in reality, we can come up with the ex ante real interest rate, okay? Or you can take that as your minimum required rate for your investment, okay? And now here, if we use the Fisher equation, we believe that your expected return from this corporate bond should be 5% plus 2%, which is equal to 7%, right? Because we said the nominal interest rate equals the real rate plus the expected inflation, right? That's a Fisher equation. Now we find that here on the market, this corporate bond offers 8% in nominal interest rate, which is 1 percentage point higher than your expected rate, correct? So your decision is to go ahead and purchase this corporate bond, okay? Because it's higher than your expected return. However, remember this expected inflation is just your guess, okay? We don't know that ahead of time, so this is your projected rate. Now, what happens is if the actual inflation rate is 4%, so we're talking about, let's say you purchase this corporate bond, let's say in January 2021, okay? And then in December 2021, when the whole year is gone, the government reported the actual inflation in that year is 4%. Now, what is happening to your investment? Remember, the corporate bond offers 8% nominal rate, right? That's guaranteed. That's in the contract. This is something you cannot go back and change, right? Now, if the nominal interest rate is 8% and the actual inflation rate is 4%, your ex post real interest rate would be 8% minus 4%. So it's going to be 4%, right? Your ex post real interest rate would be 4%. Now, go back and look at what we said before. Your minimum required real interest rate is 5%. In other words, you could earn 5% from your stock investment. Now you only earn 4% from your corporate bond investment. In other words, you did not maximize your profit, or you made the wrong investment decision, right? Once again, the point here is expectation matters. Okay, that will change your investment decision. Okay, suppose you can, you figure out inflation, the inflation rate correctly at the beginning of the year. You believe it's 4% here, so you would ask 5% plus 4%. That will give you 9% nominal interest rate on this corporate bond, right? But it offers only 8%. So you're going to walk away from this. You're not going to purchase the corporate bond, right? However, because you hold a relatively lower expected inflation than the actual one, that's why you did not make the right investment decision, okay? So here, because we find the expected inflation is the crucial here factor. So let's check out the expected inflation and the nominal interest rate. Okay, and once again, this is a U.S. data from 1954, 53, 54, all the way to the recent years. Once again, let's focus upon the long-term relationship instead of the short-run fluctuations. Okay, and we find a positive correlation between these two. Okay, in other words, for most of the time in history, we find the expected inflation goes up, the nominal interest rate goes up as a result. And vice versa, the expected inflation goes down, the nominal interest rate goes down as a result. Okay. All right, and towards the end of this chapter, you find that the author discussed the money demand function, okay, by looking at the real money balance, and then use the opportunity cost to help us understand the cost of holding money. Okay, and he also talked about the future money and the current prices. Okay, to finally derive the money demand function. Because this part of the discussion is quite straightforward, so I'm gonna leave these for you guys as a reading assignment. All right. So upon this moment, we already finished our discussion in this chapter. Okay. So on the next video, I'm gonna wrap up the discussion and draw some important conclusions.